All right, here we go with 12-4A. We're down here in Palm Springs again. When I say we, my son's out playing golf, but Dr. Kalen's over there, either reading her medical journals or playing poker, one of the two. I'm betting on the latter. Get it? Betting. Ha ha ha. All right, we are going to uh, dive into similarity some more. I love it. Yes, the basic similarity theorem. Okay, so remember, what are the two things that similarity means? See if you can remember what they are. And again, throughout these videos, I know we're kind of, getting back into these. Make sure that you're really trying to do as much of this, like when I say pause it and try it, make sure you're doing that. Okay, so what do you think? What did you come up with? Did you come up with corresponding angles are congruent? And what about what's the deal with the sides? Right, corresponding sides are proportional. Okay. And remember, in a triangle, we know that one gives us the other, and we're now going to prove it. Okay, so we have the AAA similarity theorem. Notice that does not say congruence. So this is not a congruence theorem. This is similarity with AAA. So if corresponding angles are congruent, then the correspondence is a similarity. Okay. All right. And let's take a look at this. So we have proof here. We have triangle ABC, we have triangle DEF, obviously not the same size, but you're told that A and D are congruent, angles B and E are congruent, and angles C and F are congruent. And what I've done is I've kind of overlapped these triangles so that, points A and D are right here. So you see how I took this triangle and kind of laid it in there? All right, and I've marked up everything that was congruent. Looks like I used different markings. Interesting how I did that, but whatever. I think you guys can follow along. And what we need to prove is that AB over DE is equal to AC over DF. Okay. All right. So here we go. I want you to go ahead and see what you can come up with there based on what you're given and what we know. All right, so obviously we'd start with our given info. And then we can say that angle AEF is congruent to angle B, and we know AFE is congruent to angle C. That was also given, right? Just written in a different form, I guess. And we know that EF and BC are parallel by cap, okay, right? And therefore, we know AB over DE is equal to AC over DF by side splitter. Remember side splitter? Okay, if you don't, go back and take a look at it because it's important. All right, and then we have the AA corollary, which basically says you only need to have two pairs of corresponding angles congruent to have similarity. And I'm sure if you think about it for about 3 seconds, you would know why. Yeah, if you have two pairs, don't you have the third? If you know that two pairs and two triangles are congruent of angles, the third angles have to be congruent too, because both triangles have the sum of the angles adding up to the same thing, 180. Okay, and then we have triangle cutter, okay? Triangle cutter, and you'll see why this is called triangle cutter in a second. If a line is parallel to one side of a triangle and intersects two others, then it cuts off a similar triangle, okay? And we kind of know we could go to side splitter for that, and then we know that there's going to be proportion and so forth. So, I mean, I think it pretty much makes sense. So basically, you're going to use triangle cutter if you want to go straight to triangles being congruent. If you want to get to proportions, then you're probably going to use side splitter. Okay, so our given would be that EF is parallel to BC, right? Because here, if a line is parallel, so our conditional statement is if the line's parallel to one side, so EF parallel to BC. And what are we trying to prove? We're trying to prove that AEF is similar to triangle ABC, okay? So how do you think you can do it? Take a look and see if you can figure it out before I uncover. All right, so we could say that AEF and ABC are congruent and that AFE and angle C are congruent by PCA, okay? And then what does that mean? Does that mean we have AA? Simple as that. Okay, now, oftentimes you're going to be asked to figure out or to prove that proportions are congruent, okay, or they're equal. And a good way to do that is to prove similar triangles, okay? So keep that in mind. It's gonna be important. All right, so let's practice. So you have this diagram here. I've got it covered up because I've marked it up. So go ahead and you're given that angle 1 is congruent to angle B. You're trying to prove that triangle AXY is similar to triangle ABC. Go ahead and mark it up and see if you can come up with a game plan. I'll give you a hint. It probably involves something that we just did in this lesson. All right, I'm going to uncover now. Hopefully you've given this a good college try. Okay, so there's how we've marked it up. I'm saying that 1 and B are congruent. This angle is congruent to itself in the two triangles. So angle 1 is congruent to angle B, given. Angle A is congruent to itself by identity. And wow, look at that. We have AA. Simple as that. Okay, let's go on to the next page. Okay, let's try this one. You're given that angle 1 is congruent to angle 2. You need to prove that AB times CX equals DC times EX. And I don't know about you, but for me, it's often difficult. Like I always want to figure out what proportion made these cross products. And remember, it's always means equals extremes, right? Or I guess it's means equals extremes. AB and CX would be the extremes. So if we're going to have AB times CX, I know AB would either need to be up top here, or I mean, and CX would have to be in a different spot. Or if AB was here, CX would have to be here. It doesn't really make a difference. But I always like to set up the proportion, and then when I look, I can kind of get a better sense of what I'm trying to prove, right? So, you know, this kind of tells me that I need to prove that, you know, these two triangles are similar, okay? All right, so how am I going to do that? Well, hopefully you got that we have vertical angles, and if we have vertical angles, then what do we have? Yeah, we have that, right? Now, we're not quite done because we do still have to get to the cross products here. So how are we going to do that? Well, if we know if the triangles are similar, we know that we can write a proportion. The sides are in proportion. So we could say AB over DC, right? Because they correspond, equals BX over CX, okay? And then look what happens when we cross multiply. Means equals extremes or simplification. And by the way, notice how what I set up here, just to kind of give me a sense of how to do the problem, was a little different than what's here, but it doesn't really make a difference. Isn't it true that this proportion is the same as this proportion, right? Can't I take AB and put it over CD and put BX over CX? Yeah, totally the same. Okay, good. All right, and then let's try this one. So we're given triangle ABC with altitudes BY and AX, and we have similar triangles there. You need to prove those cross products. So again, I would suggest writing out a proportion that would multiply to get you those cross products, perhaps to give you a better sense of what you need to do in order to make those last couple steps. So try that. Okay, I'm back and I'm gonna uncover now. Hopefully you marked up your diagram and you have a game plan and maybe did the whole proof. So yeah, we basically know that we're going to try and prove these two triangles to be similar. They both have a right angle. We have vertical angles there. And then it's pretty simple from there, isn't it? And because we already had the triangle similar, so kind of made this one a little bit easier. And then we have that, yeah. So yeah, I kind of said, well, I mean, you could mark up those just from looking there. So that made it pretty easy on this one. And then means equals extremes is the reason. You could probably say simplification, but I like this one better. And then obviously go by what's on Schoology. I don't know if this is accurate. This is from a few years ago, but it may be. Probably is very similar to what you have to do for your practice. All right, and I believe that does it for, yes, it does. That does it for 12.4a. And in a little bit, after doing a little practice, you'll do the video on 12.4b. See you then.